Students, this is Mr. Ivan. So this topic is on Maclaurin series, which is actually about how to use the Maclaurin theorem to get a series, a power series actually. All right. So before that, you need to have three types of skills first. Number one, all your notations. Fx, if you differentiate once, you'll get f prime x. Differentiate another time, you get f double prime x. Same for y to dy dx to d2y dx square, which is your second derivative. Okay, next is implicit differentiation. If you differentiate fx to the power of n, power bring down, this effectively is a chain rule. Okay, chain rule. So if you are differentiating dy dx square, we can apply chain rule to this. Power bring down 2 dy dx power 1. Okay, and then now you differentiate inside. Differentiate dy dx, you get d2y over dx squared. So implicit differentiation is very important in this chapter, as well as your trigo identities. Secant square equals to 1 plus tangent square. Sine square plus cos square equals to 1, not so much. Okay, I think it's more for this. Okay, and now we will dive in. Okay, so you are given this A, B, C, D, E standard Maclaurin expansion in your MF26 formula sheet. How this comes about is not so important. You can use it to apply when needed. Okay, but I just want to show you how e power x is being derived, okay, from using the Maclaurin theorem. So over here, this guy is the Maclaurin theorem. Okay, so this is a theorem. At this stage, you don't have to understand why. If you have listened to your lecture, you will probably understand why. So now we can say that fx is equals to e power x. If I differentiate one time, I will still get e power x. If I differentiate two times, I will still get e power x. Okay, so the crucial part about Maclaurin series is we need to sub x equals to 0. So f0 is equals to 1. E power 0 is 1. F prime 0 is also 1. F double prime 0 is still 1. Okay, so now all we need to do is to apply it into the Maclaurin theorem that says that fx is equals to f0, which is 1, plus f prime 0, 1 times x, plus f double prime 0, 1 over 2 factorial x squared. And if you simplify it, plus dot dot dot, if you simplify it, you're just going to get 1 plus x plus half x squared, which is over here. Okay, so this is how we use the standard series. Okay, so for fx, sorry, in this case I should have written it as e power x equals to e power x equals to, if you need e power negative x, don't need to do the whole process again. All you need to do is to just substitute in. You can use the standard series inside. Negative x plus 1 over 2 negative x square. If you need, the next one is 1 over 3 factorial negative x cube plus dot dot dot, and that would be is equal approximate to 1 minus x plus half square minus 1 over 6x cube, and that is how we get e power negative x. If you would like to have e power negative 2x, then what you need to do, like I say, all you need to do is to put it inside the x into the standard expansion, equals to 1 plus negative 2x plus half negative 2x bracket square plus 1 over 3 factorial, and you get the drift. Okay, can the next important thing is, of course, when the series will be is valid. So you realize that a is the binomial series. Okay, the rest of them you will use it a lot in the whole of the chapter. And then for the e, for e, do not confuse it with modulus x less than 1, because it can strictly be equals to 1 as well. Okay, so I've gone through with you this part of finding the Maclaurin series of e power x, as well as substituting the x as negative x, so that you can get the power series of e power negative x.